So it's just a review day. Everything that is on the exam we've already covered. So what I'm going to do is I have two review sheets posted. One has a series of definitions on it on the first page. So it says FChem Exam 1 Review, and it says define the following. So I'm going to let you go through the PowerPoints or the book and write those definitions down because that's going to be helpful for you to remember the definitions to actually write them down yourself. And what we're going to work on the board today is more the problems. So I see. I don't think I gave you all of the sheets. Give me 1 second. I only gave you the top one. So there are 2 more pages to this. Okay. Sorry about that, I didn't even staple them. So we're going to work on just the problems, and then also this exam 1 review problems. So this sheet we'll go over too. All right, so looking at what's due coming up, so on the 9th, which is Wednesday, you have your last homework assignment due for this chapter, chapter 1C. So what this homework assignment is on our chemical properties, physical properties, chemical and physical changes, intensive, extensive, so all of the PowerPoint definitions, okay? And then the discussion as well, make sure that you're posting or replying at least twice to get those discussion points. So that is due Wednesday. The exam will be up starting on Friday, which I believe is the 11th. So I'll open it on Friday. You can take it any time from the time I open it Friday until midnight on Sunday, the 13th. So find a time where you have 2 hours uninterrupted and good Wi-Fi, good internet connection. It is 36 questions. I think all but one are multiple choice. I think one of them's fill in the blank, but the rest are multiple choice. You do have a 2-hour time limit. And then I posted some practice quizzes, and they're not worth any points in this week's folder, in the week 3 folder, so that you can see the types of questions that you'll see on the exam, and it's also given in the same format. So what I mean by that is you get 1 question at a time, you don't get a backtrack, so once you answer it, you can't go back and change your answer later. So I recommend that you do those practice quizzes. They're not worth any points, and you can take them as many times as you want. So there's 3 different ones on each of the sections we talked about, so 1A, 1B, and 1C. So lots of opportunity to practice and study, for sure. I have a lot of stuff up. So let me switch here. And let's look at some of these problems. Okay, so let's start with the exam 1 review problems. So Chem 1303, it says number 1, classify the following as a physical change or chemical change. So this isn't something I've talked about in class. This is something you would have heard me talk about on the PowerPoints. So we need to know the difference between a physical change and a chemical change. The first one is gold melting. So to figure out if that's a physical change or a chemical change, what we're looking at is when gold melts, are we changing the chemical composition of it? That would be the question you'd want to ask to figure out if it's a physical or chemical change. Because chemical change means you're changing the chemical composition. It's no longer going to be gold. It's going to be something different. Physical change is just changing the state. So you can go from a solid, a liquid, or a gas. Okay? So looking at gold melting, once it melts, is it still going to be gold? It's still going to be gold. When gold melts, it's just liquid gold. So we're changing the state. So this is going to be a physical change. We started number 1 there. Because it just went from a solid to a liquid, and we didn't chemically alter it. All right? So now, let's look at the next one, which is cheese molding. And what I mean by this is like moldy cheese in your fridge. Okay, you go in the fridge and you find a block of cheese and it now has mold on it. So is this going to be a physical change or a chemical change? It is going to be chemical because it is no longer cheese. It's mold on it. Something new grew. Okay.
We can write on this?
Yeah, that's yours to keep. And let's look at the last example. So photosynthesis. So when I'm talking about photosynthesis, plants where they take carbon dioxide and sunshine from the air and they spit out oxygen.
You said it's a plant?
Yeah, the plant process photosynthesis. So do you think that's going to be a chemical or a physical change? Chemical. They took carbon dioxide, one compound, so carbon dioxide being CO2, and they spit out oxygen. Okay, I mean, it's more complicated than this process here, but notice it changed. There's chemically changed. That would be chemical as well. All right. Let's look at number 2, intensive and extensive properties. So for intensive properties, those are independent on the amount, so the amount does not matter. Extensive properties are dependent upon the amount. Okay, so in the PowerPoints, I believe I said you need an extra amount for an extensive property. Way to remember. Intensive, independent of the amount. Extensive, they do depend on the amount. So to classify these, so let's look at 2A here.
Wait, extensive is independent and extensive is who? Dependent.
It depends on the amount, yes. Extensive depends on the amount. So if I was taking the mass of a pencil, okay, so what we're asking ourselves is, does mass depend upon the amount? If I have a large pencil versus a small pencil, is it going to weigh different?
Yes.
Yes, so it does depend on the amount. It depends how big your pencil is. Right? If I have a big pencil, my mass is going to be higher. If I have a small pencil, my mass is going to be lower. So the amount does matter. So would it be intensive or extensive?
Intensive.
The amount matters.
It depends.
So this one's going to be extensive here. Let me
Oh,
tell you
okay,
why.
extensive.
So extensive. Because extensive depends on the amount.
Gotcha, okay.
So mass is always going to be extensive. Because of mass, it depends how much you're putting on the scale, right? Volume. Volume's a good extensive property as well, because it depends how much you put in the glass, right? The more volume you add, the amount's going to go up. Length would also be an extensive property. If you're measuring something with a ruler, it depends on the length. So like if I went and got this meter stick, whatever I'm measuring, it depends on the amount, right? It depends how big it is for the length. Length will vary depending upon the amount that I have. I might have answered some of these other ones then. So let's look at density. And this specific problem says density of gold. It doesn't matter. It could be density of water, it could be density of aluminum, okay? We're basically just looking at the property density. So let's see, does density depend on the amount? Okay, well, let's see. I'm going to do an example with water just because I know the density of water off the top of my head, and I don't know the density of gold off the top of my head. So the density of water is 1 gram per mil. Okay, so this is water density. Now, does it matter how much water I have? Will the density change if I had a drop of water versus a whole bucket of water?
Changes.
So I said the density of water is 1 gram per mil. So if I have a glass of water and a bucket, what's the density of my glass of water? The volume's smaller, but is the density? What's the density of water? 1 gram per mil. Okay, so my glass of water, the density is going to be 1. My bucket of water, what's the density of that water?
It'll be more.
The amount is more, the volume is more. The density is going to be the same no matter what.
Okay, stays the same.
Okay, so this is the difference between extensive, depending on amount, and intensive.
It don't change.
Because it's not going to change. It doesn't matter how much water I have. The density of water is 1 gram per mil no matter what.
Okay.
I could be talking about a whole lake of water. Okay, the density has to be 1. That is its property. So this is going to be intensive because it doesn't matter. So it doesn't depend on the amount. I also have some, let me see if I can get you. I did these just before I came, so they're kind of a mess here. If you look on the other sheet, the packet, so it's not stable, but this is posted online. If you follow the definitions down, you can see intensive and extensive property. You have to fill in the definitions. But you'll see that I put some examples. So I'm looking at, for instance, number 8, where it says intensive property. And an EG, those are 2 examples of intensive properties. Densities and intensive property all the time, no matter what you're talking about, whether it's gold, aluminum, or water. So another example of an intensive property would be temperature. I have written there. Okay.
Temperature doesn't change?
So it would be like boiling point.
Okay.
Or freezing point. Okay, so let's use water again and look at, let's look at the freezing point of water. So what does water freeze at? Well, it depends if you're talking about Fahrenheit or Celsius. But it freezes at, is it 32 Fahrenheit? And then 0 Celsius. So whichever one you want to do, right? If it's cold outside, if it gets to 32 and it's winter and it had just rained the previous day, you want to be careful because it might freeze and the roads might get icy, right? So is this an intensive or extensive property? Okay, well, does it matter how much water I have? Is the freezing point going to change because I have more water? No, this is always the freezing point of water, no matter what. Okay, it doesn't matter if I have a whole lake of water, it's going to take longer for it to freeze, but it's still going to freeze at 32 degrees. Okay, so this is also intensive. Is that making a little more sense now? Okay. And if you haven't watched the PowerPoints for, and you might not have because it's in the week 3 folder, for chapter 1C, I go through these definitions again and I give more examples than just this. So a wider array of examples, I should say. All right. So let's go to number 3. We're going to express the following in scientific notation and indicate the number of significant figures. All right. So 0.0003. So this is the normal notation, and we're going to represent it in scientific notation. That last field, SF, that's just counting sig figs. It's just to make you aware of sig figs because it's important when you go from normal to scientific and back again that you are taking into account significant figures. So I like to count significant figures right away before I start moving decimal points around. Because then I won't get confused, okay? So there is a decimal point here. Do these first zeros count?
Yes, because it's a decimal.
Zeros count when there's a decimal, but only if you already started counting. I can't start counting till I get to my first non-zero number.
Gotcha.
So
they don't count.
They can't count because I start counting at the 3.
At the whole number.
If there's zeros after that, those ones would count.
Okay.
But the ones before can't because I have to hit a non-zero number first.
So it will be 1?
It's just 1 sig fig for this one, correct. Okay, now we want to put it in scientific notation. So the rules of scientific notation are I want one non-zero number to the left of the decimal. So where is my decimal going to go? After the 3. Okay, so it's basically going to be, you don't have to leave the decimal there. It can be without 1. It's not going to change anything. But this is where my decimal would go, because I would have one non-zero number to the left. Okay. Now the next part is to figure out what the exponent itself is going to be. So the number of the exponent is how many times I have to move the original decimal point to get it in the new spot. So let's count and see.
1, 2, 3, 4.
4. Yes, it is going to be a 4. I moved to the right. My original number was less than 1. So is that going to be a positive 4 or a negative 4?
Positive. No, to the right, negative.
Negative, yes. So if your original number is less than 1, or you move your decimal point to the right, it's going to be a negative exponent. So 20.0, let's take that guy and put it in scientific notation. Before I do that, I'm going to count my sig figs. So we know the 2 counts. This is where I start counting. Do those zeros count? Yes, why?
Because there's a decimal.
Because there's a decimal. So now these zeros count because there's a decimal and I started counting at the 2. So any zeros after the 2 are going to count. So I have a total of 3. All right, where do I want?
Hold on.
Yes, go ahead.
So on the first one, we started counting to get our, how you say it, scientific figure? Significant figure?
Significant figure, we can't start counting till our first non-zero number. So we started counting at the 3.
Okay, but you automatically off the top, we don't even count zeros, correct? So when you move down to 20.0, you just automatically look at the problem and then you say, okay, my first number, whole number would automatically be 2, but you're not counting with the decimals. Like, could you go back and count left? I'm trying to see if I can make sense to it.
So
At the decimal right there.
this decimal, yes.
So you did 1, 2. That would make it 2 significant figures?
No. So when you start counting significant figures, you always count from left to right.
Left to right. That's it.
Whatever non-zero you hit first, that's when you start counting.
Left to right.
Yep. So since this 2 counts, that's the first one I'm counting from left to right. That's my first non-zero. Since there's a decimal, any zeros after that 2 will also count.
But if it was a comma, you stop.
Comma, no. Yeah. If it's a comma, they don't count.
So what if that was like an 8 where that 0 was at and it was a comma? Do I stop counting at that first 0?
So you're saying if it was like this,
20. No, 20.8.
20.8?
Or I mean 20, comma 8, something like that. 20, comma 8.
Like
So
this?
you know zeros, when the zeros don't count when it's a comma?
Okay, so for a number like this, we'd start counting left to right again. We'd start at the 2. Okay, so this is my first one.
Right.
Okay, now I hit a 0. I'm not sure if it counts yet. So I'm going to keep going and see if there's any other non-zero numbers. And there is. There's an 8. Okay, so these 2 count for sure.
Right.
Right? The 0 in between them has to count.
So it'll still be 3.
Yes, but these ones, since it's a comma, these zeros do not count.
count. Gotcha. Okay.
Is that cleared up?
Yeah.
Okay.
I'm sorry.
No, you're good. We're going to be using sig figs the whole semester. We want to make sure that
Yeah.
we're really getting it. So questions are good. Okay, 3 sig figs. So I'm going back to this one so we can put it in scientific notation. So I don't want my decimal there. I want it so there's one non-zero number to the left. So where is it going to be? After the 2. So between this 2 and 0. So that way I have just 1 to the left. Okay. So when I write it over here, I'm going to have 2. And I'm going to include those zeros because I said they mattered. So that's why I'm keeping them in this case. So 2.00 times 10 to the, and then to figure out the exponent, it's how many times I have to move that decimal to get it in the new spot. And it's just one time, right? Notice this time I moved to the left.
Positive.
So it's going to stay positive, yes. And my original number, it was 20, it was bigger than 1. All right. Another one. I tried to pick ones where this counting significant figures was a little trickier, just to get practice at it. All right, let's count our sig figs first. So I start counting left to right, but I can't start till I get to my first non-zero number. So where do I start counting? What number?
4.
The 4. Okay, so that 8's going to count just because it's not a 0.
So it's 2.
But does this last 0 count?
Yes.
Yes. So 3 sig figs. And it counts because it's decimal. Okay? All right, so that means I want 3 over here once I have my answer.
Could it be a possible 0, 0480? Is that possible?
No, because
Okay.
you wouldn't, if you have a decimal, you won't have commas anymore. So. All right, so where do I want my new decimal point? Between the 4 and the 8. Okay, so I'm going to get 4.80. Keeping that 0 because I said it was important.
Stop right there, please.
Yes.
Now that's why I'm getting confused, I think. How do you know where that first decimal is going to go?
The blue decimal,
Yes.
because you always want just one number to the left. So if I had started here, I wouldn't want to put it here because now I have 2 non-zero numbers to the left.
This way, okay.
And I wouldn't want to put it here because there's no non-zero numbers. There's only zeros before it. So I look and I go, okay, where did I start counting? Where's my first non-zero number? I started counting at the 4, so that's what's going to be in front of the decimal. That's basically what we did in all of these, right? What number did I start counting at? Okay, that's where I'm going to put my decimal, right after that first number I started counting at. All right. So let's see how many times we move it. And this time we're moving to the right 2 times. So we move to the right. The original number was less than 1. So is it going to be negative or positive? It's going to be negative, just like this one up here. We moved to the right, so it was a negative exponent. Same thing here. Move to the right, negative exponent. All right. So that was just scientific notation. So the next question, number 4, we're doing something similar, except for this time it's in scientific notation and we're going to put it in normal. Okay? So, write this down here. Do you already have them written? Takes me a minute. I'll just write them all at the same time. Wait, I'll pick this up. All right, so let's put these in normal notation. So notice they're all in scientific, they all have just one number to the left of the decimal. Okay? So let's start with the top one. 4.27 times 10 to the first power. So this exponent, this is what's going to tell us how many times we're going to move that decimal. Okay, so whatever it says, if it says 1, that means we're moving the decimal once. If it says 5, that means we're going to move that decimal 5 times. To figure out the direction, we're looking at if it's positive or negative. If it's positive, that means the number is going to get bigger. Okay, positive exponent means it's going to be bigger. So we're going to want to move to the right to make it bigger. If we have negative, that means it's a tiny number. We want to make it smaller, so we're going to move to the left however many times it tells us to make it smaller. Okay, so that top one, we're moving it once. And what direction are we gonna go? Right? Because we wanna make it bigger. So I'm gonna go to the right just one. So that's where my new decimal point is. So 42.7. I forgot to count my sig figs before I started, but it's never too late. We can still count them. So this does have 3 sig figs. The reason I know that is because there's no zeros, so they all count. All right. So before I start moving the decimal on this one, I'm going to count the sig figs though. Okay, so I start counting left to right at the 2. That's my first one. The 1 counts because it's not a 0. Do these 3 zeros count?
Yes.
Yes. Why? Because there's a decimal and we started counting at the 2, so every 0 after that will count. Correct. So there's 5, right? Yeah, 5 sig figs. Right, now that we know there's 5 and we need to keep 5 numbers in our answer, let's
Put it together,
change
take out
it.
the decimal.
Yes. So I'm moving the decimal how many times? 3. What direction? Do I want to make it bigger or smaller? Bigger. So it's going to go to the right. So 1, 2, 3. So now it's between these 2 zeros. So I'm going to write 2, 1, 0, 0, and then my decimal, and another 0. So that's the normal notation. And I still have 1, 2, 3, 4, 5 sig figs. All right, count sig figs on this one. How many? 3, right? This 0 counts. Why does it count? Decimal. Exactly. So we're going to take that decimal now, we're going to move it. How many times are we going to move it?
5.
5, yep. And it's negative this time, so we want it to get smaller. So to make it smaller, I'm going to go to the left. 1, 2, 3, 4, 5. So here's my new decimal point, and what's going to go in these empty spaces are zeros. So I have 1, 2, 3, 4 zeros that I'm going to add in. So when I write this in normal notation, I have those 4 zeros that I had to add in, and I kept the 1, the 5, and I kept that 0 so that there are 3 sig figs. So remember, if we're counting sig figs on this guy, we don't start counting till we get to our first non-zero number.
The 0 that's in front of the decimal, if we didn't put that, would it be considered wrong, or you have to always?
No, I put that just for a placeholder.
Okay.
Just so that people can see a little bit better where my decimal is from the board. But no, you don't have to put that in there. And the exam is, I think, all except for one problem, multiple choice. So I will have the 0 there.
Okay.
Is it gonna be like this and like some, the same, similar to?
Similar, yeah. So like I would maybe give you this number and I'd say, what is that number represented in scientific notation? And you would have 4 different choices. So I would probably give you this choice. I'd give you where there's a positive 4 as a choice, so that, because I want you to recognize, you know, that it's the negative 4, not the positive 4 exponent. And the other choices, like I try to give you viable choices. You know, I might give you something like that, so that you recognize, no, this has 2 sig figs. You wanted just 1. So, even though it's multiple choice, it's still, you need to know what you're doing, you know?
Girl, I can see it. It's like I'm trying to keep my serious man.
There's so many things for you, help you study for the exam though.
And there's
like-
a book too that you can practice. The book.
Yep, the book has practice, it has practice quizzes, like it tests you as you read. And they do extra problems too, so I mean,
We need a book for this one?
it's